Alright, hello, my name is Reginald Seay, and today I'll be going over a problem over Fourier transforms. Uh, we have these two functions. One is a step function, and the other is a function which has e to the t. So the question says to evaluate the frequency domain response of the two signals. Okay, so for the first one we have x of t is equal to u of t plus 2 minus 2 times u of t plus u of t minus 2 plus u of t minus 2. And then it says evaluate the Fourier transform from the table. So to do this, we're going to go and we're going to say x of j omega is equal to the integral from -1 to 0, and this is the first part that we have, the u of t, the 2u of t, and the u of t plus 2, and that is the integral from 0 to 1 of e of negative j omega dt, and then we're going to subtract that by the integral from 0 to 1 of e to the negative j omega t. And then once you do that, those computations, you should get out as your answer 2 cosine omega minus 2 over j omega. Okay, and you get that from doing just basic integration, and these two this formula is what we get from the two signals that we have, the two frequency domain responses. And then we can also write this as x omega is equal to, and then we have the 2 cosine omega minus 2 over j omega as the first part. Oh, sorry about that, I wrote that wrong. For the first part, we're just going to set up this little small interval. For the first part, we have 2 cosine omega minus 2 over j omega. Over j omega. And then this is when omega is not equal to 0. So from the two signals that we have, we can say when j is not equal to 0, because we have both of these signals, both of these x of t's with each other, the x of t of the u of t plus 2 minus 2 u of t plus u of t minus 2 and u of t minus 2 for this first part, and then the other one, which we're about to do now. And then it's 0 everywhere else on that interval when omega is equal to 0. So for the second one, we have x of t is equal to the exponential of -1 plus the absolute value the negative absolute value of t, excuse me, and then that's times u of t plus 2 minus u of t minus 2, and then we're going to evaluate this one like we did the other one before. So we have x of j omega, and these j omegas are in replace of s's. So if you were doing the Laplace transformation of these two frequencies, then they would be s's instead of j omegas. So basically, if you are familiar with Laplaces, the s's would be j omegas. So we say x j omega is equal to the interval from -2 to 0 of e of t times e to the negative j omega t dt, and then this is plus the interval from 0 to 2 of e to the negative t times e to the negative j omega t and these are both being multiplied times dt, because it's both of these equations are with respect to t when you take the integration. And then we do a little bit of algebra, do some integration, and we get, for the first part of the equation, which is the left half, the e to the t times e to the negative j omega t dt, we get 1 minus e to the negative, and this negative is outside the parenthesis, negative 1 minus j omega times 2, and this is all over 1 minus j omega. Okay, so this is the left half what we have. So this is from our interval of -2 to 0. And then for the right half, we have 1 minus e to the negative 1 plus j omega times 2. And this is all over 1 plus j omega. So the left half basically looks exactly the same as the right half, but the only difference is our intervals. So we had a -2 to 0 as our left interval, and a 0 to 2 for our right half interval, and then we also had a negative t for the right half, or the right interval, and just a regular t for the left interval. So that's just the main difference, and the only difference that changed is making 1 plus j omega for the exponential and the denominator, and 1 minus j omega for the exponential and the denominator of the left hand side one. Okay, so when you do those and you just combine them together, doing some more algebra, you'll get the final result as being 2 minus 2 times e to the negative 2 times cosine of 2 omega, and then this is plus 2 omega e to the negative 2 sine 2 omega all over 1 plus omega squared. So when you combine both of these together, after you do the integration, your j's will disappear, so everything will just be in terms of omega. So that's what we did when we did the top one. In part A, we did our integrations and our j's disappeared because we had x omega, and we set up our intervals from 2 cosine omega minus 2 over j omega, and then it was 0 everywhere else. So this bottom one is basically our x omega. So you have 2 minus 2 e to the negative 2. Alright, thank you for watching.